My humble greetings to all the students. Today we are going to discuss linear dependence and linear independence. Consider x1, x2, x3, so on till xn be vectors, and a1, a2, a3, so on till an be or belongs to real numbers. First we'll discuss about the linear combination of vectors. So a1 x1 plus a2 x2 plus so on till an xn is called a linear combination of vectors. It is a linear combination of vectors. Moving to linear dependence, if the linear combination of vectors in this case will take two vectors, a1 x1 plus a2 x2 equals 0. If this equation is satisfied such that a1 is equal to a2, not necessarily a1 and a2 are 0. Not necessarily a1, a2, both a1, a2 need not be 0. This is called the condition for linear dependence. We'll take up an example. Now for example, if I take two vectors 1, 3, let this be x1, and x2 be minus 3 minus 15. You can clearly see here it is a multiple. This is a multiple of x1. So 1, 3, I'm sorry, this is not a by. 1, 3 x1, which is x1 equals 1, 3 can be written as minus 5 x2. This is x2. If such relation is satisfied, it is a linear dependent equation. Moving to linear independence, this is a1 equals a2 equals a3 must also so on till an must equal 0. This is the condition for linear independence. We'll take up an example again. Consider 1, 0, 0, 1. We can clearly see here that a1 x1, this is x1 and this is x2. a1 x1 plus a2 x2 equals 0 satisfied only when both a1 equals a2 equals 0. This is satisfied. We'll elaborate on it. So we'll multiply it by scalars. So a1 plus 0 a2, this is 0, 0 a1 plus a2, this is all equal to 0, right? So what will happen now is a1 equals a2 equals 0, indicating linear independence. Physics students, or for that matter even mathematics students, will immediately see that these are the examples, these vectors are the examples of a unit vector in, this is the x direction, and unit vector in y direction. So now if I take the xy plane, unit vector in y direction is this, unit vector in x direction is this. We have now proven that they are linearly independent. That's the reason x and y axis are actually taken, because they are orthogonal to each other, which we will discuss in further discussions that we have in quantum mechanics. These are also the z axis, these are all mutually perpendicular. Now in two dimensions, this is linearly independent. Okay, have a nice day. Bye bye.